In this section, we want to talk about compound interest, and first we'll look at how that both relates to and differs from simple interest. In example 1, assume that someone invests $14,015 in a CD, earning 7% interest. In part A, we want to determine how much that CD will be worth after 3 years if this CD offered simple interest. We can calculate that amount as the principal plus the interest earned. And since we're talking about simple interest, that interest would be calculated as principal times rate times time. In this case, that means $14,015 plus $14,015 times 0.07 times a time of 3 years would give us $16,958.15. In part B, now what we want to do is calculate how much the CD will be worth if interest is compounded annually. To do that, we'll look at how much money would be in the investment after 1 year. To calculate that, we would take our principal of $14,015 plus $14,015 times 0.07 times 1. So what we're doing here is just taking the principal plus interest, using that simple interest formula, over the course of 1 year. So at the end of 1 year of simple interest, we would have $14,996.05. At the end of year 2, we would apply interest again, or calculate interest and add that to our principal. Now our starting principal is $14,996.05, and we would add to that the principal times the interest of 0.07 times 1 year to get the new balance of that investment as $16,045.77. Then we would calculate how much would be in the investment at the end of year 3 by repeating this calculation again, but starting with our new principal, or our new beginning balance of $16,045.77 plus that principal, that new principal, times our interest rate times the time of, again, 1 year, would give us $17,168.97. So we can compare these two values. In the first case, using simple interest over 3 years. In the second case, compounding annually, meaning we calculate interest earned each year and add that to the principal. Doing that 3 times, we see that in the first case, the total value of that investment was $16,958.15. If we subtract that from the balance from compounding annually, that's $17,168.97. We can see that compounding interest annually generated $210.82 more than calculating interest with just simple interest. So again, with simple interest, we calculate the interest once at the end of 3 years and apply that to principal. With compounding annually, we calculate that interest every year and then add that to our principal. With the general idea being that as we compound annually, we're going to see that investment grow faster than we would with just simple interest. Now, that process that we applied above of calculating each year step by step would become very cumbersome, especially if we talk about investments that last maybe 10, 20, 30 or more years. So now what we'll do is introduce a formula for calculating compound interest. And looking at another example, an investment with a principal of $7,548 and a time of t equals 20 years. We want to calculate the future value of this investment with a simple interest rate of 2.75%. So the total amount in that account would again be the principal of $7,548 plus the principal times that interest rate of 0.275 times a time of 20 years would give us $11,699.40. In part B, we want to repeat that calculation, but now using interest being compounded annually. If we were to do this like we did in example 1, we'd have to repeat that calculation 20 times. So instead, we're going to introduce this new formula for compound interest. And what we'll do is in Desmos, when we switch over to that in just a second, we'll evaluate this for a value for P, our principal, which is $7,548, an interest rate of 0.0275, a time of 20 years, and this value for N, we'll talk a little bit more in just a minute, for right now is going to be a value of 1 to represent that we're compounding annually. Switching over to Desmos, where I already have this formula set up, we can evaluate A of 7,548, 0.0275, 20, and 1 to get a value of 12,985.7937, etc. So rounding this is going to give us a future value of this investment with interest being compounded annually of $12,985.79. And then comparing those two values, just subtracting to take that difference, we can see that over these 20 years, compounding annually generates $1,286.39 more for that investment.